what I want to focus on is protective clothing, but especially textiles, and what we're doing in the industry, in the textile industry, to help reduce the contamination of the fabrics, and how we can better produce fabrics that are more easily to clean. So I have one question for you. Who's wearing clean underwear? This will all make sense in a second. Those of you that are wearing clean underwear, can you please stand? Some of you are worrying me back there. Okay, stay standing for me. Keep standing if you currently in your department have an SOP that dictates when cleaning is done for your structural ensemble. Those of you that do not have an SOP that dictates your cleaning, sit down. Okay, good. Stay with me. Second question is, if you do have an SOP, does it dictate that you clean your ensemble after every ideal H exposure? That includes your helmet. After every ideal H exposure, do you take your helmet apart and clean it? Okay. Third question. Those of you left standing, do you have an SOP that dictates your station wear being cleaned after every ideal H exposure? Okay, what I'd like you to do, those of you that are still standing, and those of you not standing, turn around and look at the number of departments that follow the NFPA 1851. There's 4 of you? Okay, here's my point. NFPA is a minimum standard. And when I was an active firefighter at Local 1395, I was given the task for our department to follow. You can sit down, thank you, the 4 people standing. What I am truly in hopes of is that you go back to your departments, and the IAFF almost everywhere has given up something for a seat at the table, correct? At the health and safety table. And my point is this, I want you to be the advocate, and we should be the advocate, to at least force our departments to follow the minimum standard concerning cleaning protective clothing. Agreed? Okay. Textiles. I do work for a textile company. Over the last 50 years, when we went to completely FR fibers, our main focus is thermal protection. And I go around the country all the time talking about how well your protective ensemble protects you. When we're talking about your basic jacket and trouser, this is the thermal protective performance test that we all have to comply to, and that is simply 1800 degrees, direct flame, radiant heat, and your ensemble has to keep your skin from blistering for at least 17.5 seconds to pass this test. And those of us in the textile industry is very good at passing this test. But now we have a new issue, and that new issue is what can we do in the textile industry to affect a change in producing a different textile that may make it easier to clean and decontaminate that fabric. I want to introduce you to the aramid fibers that we use to spin yarn out of is somewhere typically between 12 to 15 microns. As you see, human hair is roughly 50 to 70 microns. The new 1971 particulate barrier is between 0.1 and 1 micron, but the moisture barrier that's in your structural ensemble is down to 0.027 microns, stopping bloodborne pathogen liquids. So we know that the majority of particulates is getting inside, and you've seen multiple pictures of the FAST test, but I want to focus on ultimately what can we do from a textile standpoint to make things cleanable. So this is a picture of one yarn, and when we say we spin yarn, what we do is we take those fibers, we mix them in the right percentages, we line them all up, and then we twist them into one yarn. So easily one yarn has somewhere between 200 to 300 individual fibers. This is one yarn, and this is, we've already figured out that particulates are somewhere between 0.1 micron and 1 micron. So my first point with this is we are concerned with cleaning. We're all concerned with what does cleaning do to that yarn? How fast does cleaning degrade a yarn? But I also want you to think about how much damage does these particulates do to the yarn that are left in the fabric? So that is a consideration. What can we do as a textile manufacturer to make this yarn more cleanable? Or what is the cleanability of that yarn? So there's three things that we're looking at and studying today. We're studying what is the right diameter. Can we increase the diameter of each one of those individual fibers? Second thing, each one of those fibers today is exactly 2 inches long. If we were to increase the length of fiber, would that make a difference? And last, considering yarn manufacture, is how many twists to that yarn do we put in it? If you twist a yarn too much, then it becomes brittle. If you don't twist it enough, then it doesn't have the tensile strength. So can we manipulate the amount of twists that we put into a yarn to aid in the cleaning of that yarn? You've seen a lot of fast pictures. The whole point of do you have clean underwear on is sometimes we think we have clean underwear, but the reality is we don't have clean underwear because we're not taking, we have particulates that are obviously getting in through our protective clothing to our skin. So from a garment side of this, the protective side of this, there's a couple things we know. One, we know if things are properly donned can make a tremendous difference in the amount of particulates that gets to our skin. This is on the left is a does not have a particulate blocking layer in it and not properly donned, where there's gaps between the mask and the hood. But if that non-particulate blocking layer hood is donned appropriately, it makes a tremendous difference in the amount of particulates that gets to the skin. If you add a particulate blocking layer, obviously that's part of NFPA 1971, that also will make a tremendous difference. Garment manufacturers are looking at how do we slow down, how do we reduce the amount of particulates that are getting in between the coat and the pant, between the pant and the boot. So manufacturers are coming up with multiple ideas in the interfaces between the pant and the coat. Lastly, I want to look at the weave of the fabric. So there's multiple weaves. We're all sitting here with multiple different weaves on today. Traditionally, this is an outer shell weave. It's called a plain weave. We also do what's called a twill weave. And we're also, the last thing we're looking at from a cleanability standpoint is, does the weave of the fabric make a difference in how easily we can get particulates out? This is interesting because most manufacturers have gone to a twill weave fabric, which provides more flexibility. But it looks like there's a possibility that a twill weave fabric may be a little bit harder to clean than a plain weave fabric. So that's the fabric. We're looking at, we used to consider that 20 wash and dry cycles, was the lifespan of an outer shell. Today, we're looking at simply, we're increasing that to 50 wash dries and up to 100 wash dries. And this is a picture of an outer shell before wash and the same outer shell after 50 wash dries, and what the damage is caused simply by the cleaning process, and all the factors that I mentioned about yarn, spinning, and weaving a fabric, what we can do to make that fabric last longer, since we know that structural garment is going to stay in service longer. Up against your skin, we have the technology, and we know from a comfort level, if we produce a face cloth in our thermal liners and or our undergarments that wick moisture. So we have fibers available today that attract water. And what we're looking at is, in the face cloth of the thermal liner, if we can produce a face cloth that will wick moisture off your skin, and all your undergarments are also a fabric that also wicks moisture, will this also decrease the amount of particulates that are on your skin? Will it make a difference? Can we reduce the amount of particulates by getting them off your skin and into the fabric to be cleaned and washed and cleaned? So those are, from a textile standpoint, what is being looked at so that we can all help reduce the amount of particulates that are on a firefighter's skin. I greatly appreciate you having us and me today, and I thank you very much. Thank you.